Sun, right? A very, very important part of our solar system. So we are going to be focusing on where does the sun get its energy from, what's the structure of the sun, and then how does this affect us here on the Earth. So let's go ahead and get started. Sun's energy, first off, it's not burning, right? We think of the sun, you hear, oh, the sun is a big burning ball of gas, but it's not burning in the sense of fire like we know on Earth, all right? It's powered through a process called nuclear fusion, which is the same process that takes place inside a hydrogen bomb or extremely powerful nuclear bomb. Slightly different than a nuclear power plant, though. So nuclear fusion. And what's happening is atoms, individual atoms, are smashing together in the sun's core. So atoms smash together in the sun's core and release energy. All right? And the massive gravity of the sun is what causes this to happen. So even in the center of the Earth, there's still not enough pressure and gravity to cause this process to happen. Otherwise, we would become a star, and, well, that would be bad. So this is equivalent to over 2 billion nuclear bombs exploding every second. All right, so that's where the sun gets its energy from. So the important thing is that it can burn in space because it's not actually fire like we think of, right? It's a nuclear process that doesn't require any oxygen. So let's look at the structure of the sun. The sun has 3 kind of main layers, right? So the sun's structure. All right, we have what we call the core, right, at the center, and this is where the nuclear reaction takes place. Core is at the center, and this is where the nuclear reactions are here. All right. Next, we have what we call the radiative zone, which is the next layer out. And here, energy is moving outward from the core. All right. So energy is created down here, and then it moves outwards. And then lastly, we have what we call the convective zone. And in the convective zone, we have hot gases moving in what we call convection currents to the surface. And we'll talk a little bit more about what convection currents are in class. But you have hot gases here that move up, release their energy, and since they're cooler now, they come back down, and this forms a cycle. We'll see this also happens inside the Earth. So those are kind of the 3 main layers inside of our sun. Once we get to the surface, we have what we call the photosphere. Photo means light, sphere meaning round surface, and this is the lit surface of the sun. And this is what we see when we look at the sun. And then lastly, we have what we call the corona of the sun. All right? We can think of this as like the atmosphere of the sun. Right, layer of gases beyond the surface, and this is only visible during a total solar eclipse. Right, so you can clearly see the corona here. Otherwise, the light from the photosphere just totally drowns this out. Right, it's always there. We just can't see it because the crazy bright light from the photosphere totally blocks it out. So, kind of some cool features of the sun's surface that we see. We have areas called sunspots. All right. We still don't totally understand why these form. There's still a lot about the sun that we don't know. There are two satellites in orbit around the sun, and they continuously observe the sun to try and figure out a little bit more about it. So we have sunspots, or cooler areas on the sun's surface, and they're a little bit darker. All right. Next, we have what we call prominence, and that would be something like this. A huge loop of gas from the surface. Again, we don't totally understand why these happen. Off the surface. And if a prominence detaches and erupts out into space, we get what we call a solar flare. You may have heard of these before. So this is related to a prominence, but this is a prominence that explodes off into space. Explode into space. All right, and it releases a bunch of charged particles. And so these charged particles now go streaming off into space super, super fast. And so just to give you an idea of how big some of these prominences are, there's Earth. Hello, Earth. Fortunately, we're way farther away. But that would do a lot of damage if it would hit us, obviously. But they're not that big. Or at least not big enough to hit us way out here. So lastly, we're going to talk about what's called the solar wind and how this affects Earth. And so the sun, in addition to releasing light, releases a constant stream of charged particles. So these are particles that are kind of just streaming off of the sun at all times, right? Super fast, way too small for us to see. They don't glow or anything, so we can't see that they're there. But the sun releasing a stream of charged particles, releasing a stream of charged particles. And when this hits the Earth, it turns out the Earth has what we call a magnetic field around it. We didn't really talk about what that is, but when this hits the Earth's magnetic field, the particles release energy. So when they hit the Earth, reach Earth with a capital E because it's the planet, they release energy in the form of light, and these are called the auroras, right? Or the northern or southern lights, creating the aurora. Right, and these are the northern or southern lights. And the reason they tend to glow most at the poles is, again, because of the angle. Right? The solar wind hits the Earth near the equator pretty directly, and so those particles kind of just get absorbed. At the poles, they tend to skip off, like skipping rocks on a pond, and when they skip off, they release that energy in the form of light. And you get these crazy, beautiful displays in the sky, right? You only see these at night because during the daytime the sun is so bright that it would totally drown them out. Alright, so at the bottom again we're going to do 3 questions that you have instead of the summary, right? And we'll see how that goes. So go ahead and write 3 questions that you have. If you feel like you understand this pretty well, make 3 questions that are stuff you want to learn more about the sun. Otherwise, questions about what we talked about here. And I'll see you guys in class tomorrow to talk about the sun.